So how do we balance our minerals, vitamins, and amino acids? So I want to make sure that I have a balanced of those so I can be healthy. How do we assure the food that we are eating in the right balance and the relationship with the essential nutrients if we do not have them in the soil? So I can't see any relationship in any scientific anything tied to nutrition. If you're eating foods that are coming from demineralized soils, you're going to have. And that's probably the advent of cancers happening in the West, because we've been farming the exact same foods in the exact same place for the last 100 years. And we're demineralized the soil to a point to where we're deriving ill health tied to nutrient deficiencies. And that's why so many people say, hey, I got sick, I got cancer, and I just started eating well, right? Focusing on the food, the mineral relationship, and I got over this deficiency, basically, is the translation. And then look, I got healthy again. So we want to absorb minerals. So that's what we're going to start getting into. Where do they come from? These negatively charged particles. How do they make that relationship? So you got to have this air in the soil, and that brings us to soil pH. So what is this? Here's our chart, and we need to learn how to read it. What does it mean? And then we're going to tie this chart to minerals. So we're going to flip it sideways, and then we're going to also see all of the different plants, and we get a pH plant chart. So that's what we want to try to get to, not just understand pH, we want to understand a plant chart. So this is potential hydrogen ions in the soil. The more ions there are, the more acidic. It works on a scale of 1,000, so 1 point moves 1,000 units, basically. So it's a really big jump. So to give you an idea, 7 pure water, table water. But our saliva or urine is at 6, and seawater, which nobody would too much want to drink, that's at 8. So pretty big. I don't want to really drink urine. It's really, in that instance, acidic. And I don't want to eat the others, very alkaline. These are how far it moves. So we tend to stay within the 6.5 to 7.5 range, unless you drink Coke. So most plants that we see, the things where we derive minerals, remember, we only get minerals from plants, the plant relationship to the soil and our relationship to eating plants. Most plants thrive in a 6 to a 7.5. Very few plants will thrive outside of that range. Also, we live within that range. This gives us the best nutrient availability, plants within that range. This is derived by soil organisms, live in that range. So when we get outside of those ranges, the soil organisms die. So the minerals can't be transferred, so it's very difficult for the plant to live because there's no minerals. So plants that are basically lime-loving are called colloid plants, and califuge plants, that's lime-hating. So we'll see these two types. And our new thing that people are doing, you can purchase them in the West, people are now starting to get basically pH monitors. So you can monitor your pH, just like you would monitor your blood sugar. So the question is this, and nobody knows this answer, and this is the major issue. What's your pH right now? I've got no idea. What's your pH after you drink a coffee? What's your pH before you ate lunch? What's your pH after you ate lunch? What are you eating when you eat lunch, and how does it affect your pH? And your pH, they find, they're doing studies, has a lot to do with your mood. So our moods being swung because of our blood sugars and pH levels related to us eating all kind of weird shit that messes us up on our insulins and messes us up on our pH, okay? So we're electrically weird and we're sugar high, and then we wonder why we feel, to a certain extent, weird. So check your blood sugar. If we look at the table, we can look at this, and we also need to be very careful. A lot of these infographics created by who wants to do who to what, I don't know. They like to take all the best foods they can think about and stick on one side, and they'll pick all the worst foods that they can think about and put on the other. But it doesn't work that way in real life, because I can tell you that on the alkaline side, there's horrible things that we wouldn't want to eat. And there's great foods on this side. So Coke, yeah, Coke's in the acidic side, but so is coconut. And I don't think there's an affiliation that coconut's bad, right? You see, so we need a balance. So when we eat over here too much, then we're off of our pH. We're not staying at 7. We have to have a balanced pH. So it's like a plus and a minus equals neutral. So be careful of the things alkalize and live. Well, isn't it convenient that they're only picking products that are grown in a temperate climate? right? Because I'm from a temperate climate, I should only eat in a temperate climate. But we have to ask ourselves, where did humans come from? We've been on the planet for 28 million years. We haven't lived in temperate climates in that time period very long. Less than 0.0001% of the human race development through evolution. Have we lived in a place to eat those things? So do you think that our ecology, our evolution, derived eating that way, all the way on that side? 80-20? It's a real interesting number. We can play with 80-20. It's like a business thing, you know? And then we tie that concept and throw it into a food relationship. It doesn't work that way. So think about being balanced. And the major thing, if you're really concerned, go get the little tester. They don't cost very much. And then you can test your pH if you so choose. So here's another pH food chart. Again, they put all the bad stuff on one side and all the good stuff on the other side, but you could make a balanced chart, good and bad, right? Doesn't mean eat the bad stuff on the alkaline side, but you know. Chang beer, yeah. Yeah, I think Chang beer is off the chart. Okay. So here we go. Check out pH spectrums, look at your food. But maybe a better way to look at this type of chart, there's another 80-20. It's a little bit fairer. Actually, I know it's hard to read, but you can go find these online. But look, just go through, and you need to realize the food I eat has some relationship to it being alkaline or acidic, and then I can balance my intakes of food so I'm not eating too much on one side. So also be careful about drinks. So we drink things, and that affects us. So this is all different types of drinks. A lot of water. It starts with water. So it's really weird. A lot of the bottled water that's actually sold isn't 7, and some of it is really far off. Like imagine, remember it was 1,000 units, and like battery acid and stuff was like this one. What is it called? Aquafina is 5.35 pH when it's supposed to be 7. So that's 2,000 times off. It's like, what did they put in there? Okay. What is this? Arrowhead spring water 7.42. Not too bad. Evian is 7.64. Fiji is a 7.6. Smart water is 5.9, so I guess that's not too smart. And real alkalized water is a 7.9. So they write real alkali, but the pH is neutral. So. Marketing, I guess, guys. But if we go over to the other side to some other weird stuff, so let's look at Coke. Coke is a 2.8. Wow. Yeah. Sprite's a 3.5. What's some other stuff that they got on there? But anyway, a coffee is 5.5 from Starbucks. No, this one, they have Perrier, 5.5. No, they didn't put beer. So I'm sure you can find that online. So in that instance, just remember what I'm drinking has a relationship to me pHing myself in relationship to what I'm eating. And we kind of don't think about it at all. And the studies show that it has a lot to do with our moods and our body's ability to function correctly. So another maybe a way to look at this also, then you could look at the pH, but balancing our diets, carbs, fats, and proteins, and which of these foods, and we can put ones in the center that are like better foods that are more balanced. So if I eat this food, I get a balance of these things, but if I eat this thing, it's like way over here. So I'm only getting protein, or I'm only getting carbs, or I'm only getting fats, right? So we can try to eat more to the center. Lots of things online about that. So coming back though, that's eating, and that's why we grow good food, to eat it, and then we can try to have more balanced food. So minerals and pH. So here we have the minerals and the pH. So if we go down the 6 to 7 range, right through the middle, we catch most of the macronutrients, right? A pretty decent swap there. Too far over, they don't catch them, or too far this way, we don't catch them. So nutrient availability and microbial activity as affected by the soil pH. The wider the band, the greater availability of activity. So what we find is what we call the big 13, or the macronutrients. They're actually pretty easy to get. It's the micronutrients that we start to have problems with, because they're like kind of outside. So once we add all those nutrients, right, we start to see where we have to get on two sides and not just be perfect. If we only ate perfectly down the center, we'd end up with like macro or micronutrient deficiencies. So that's how this is. If we only ate acidic foods, right, we would have a major nutrient deficiencies, or the macronutrient deficiencies. And if we only ate alkaline foods, you end up with trace element deficiencies like iron, magnesium, boron, copper, zinc, all of these things. are not really found in alkaline foods, okay? So you have to eat balanced. That doesn't mean eat the bad stuff on each side. Eat the good stuff on each side. But realize that you can't just eat one side of the periodic table and then think that that equals health. We need both sides. And that might be, if you ask me, the biggest issue about the West's right now affiliation with so much cancer, because it's eating so much to the alkaline side, because that's the foods that are grown there, right? The alkaline foods. And they have poor relationships to trace elements and trace minerals. So do your best. So this is a chart of these minerals. The first time they ever put chemicals on agriculture was in 1951. And they only did nitrogen. That was the first one. They said, man, we put nitrogen and boom, it grows big. And at this point, they were putting nitrogen and the soil was still there. Yeah? They still had soil activity because before that, it was organic. So they started to put nitrogen, and then they would put more nitrogen. And the more nitrogen you put, the bigger it would get. But then they started to get to like a plateau. There's a level. I put so much nitrogen that the plants don't interact with the bacteria. They start to die off, and I start to hit like a plateau. I can't get any bigger, and I've killed off the soil food web, so I only can do my plants with chemicals. So by 1957, they had NP. 1960, they were at NPK. And in 1980, they figured out if they added S, sulfur. So they had NPKS. So they had size, they had color, they had taste, and they had fruiting. That was the four things that we judge. That's our judgment. And then then they said, hey, well, we're having zinc, a little issues with zinc deficiencies. And then they went up to, and then how many things do they put in the bottle now? Okay? So some tests were done in the U.S. in 1940, and then this test is from 1991, and I'm sure it's worse now. You can see a graph to show you the depletion levels of that test. So they had minerals that they tested for, and these are the types of vegetables. So in vegetables that they tested, they had sodium levels went down by 49%, and the fruits that they tested went down by 29 on average. So this is a grocery store. Potassium went down by 16, magnesium by 24, calcium went down by 46%, and then you get the osteoporosis with women needing to take calcium pills because there's no calcium in the food. And copper going down by 76%, okay? And then zinc went down by 59%. So then that's where you start seeing them having to they have to add the minerals into the field to get it into the food because it's not there anymore. It's been exported. And then we take the minerals after we taste our waste and we put it into a toilet and flush it into the ocean, right?